Hey everybody, we're in section 10, 3, and we're solving the quadratic equations by completing the square. So the last section I didn't really want to emphasize it as much. We did look at solving quadratic equations by factoring, but sometimes you're going to have equations, not equations. You're going to have quadratic equations where you cannot factor, and that's when this idea of completing the square comes in. So let's talk a little bit. First of all, I've told you that we need to, when we have equations of the form ax squared plus bx plus c equals 0, this is the typical way that we would solve a quadratic equation. We'd factor it, set it equal to 0, and do our thing. Sometimes we can't do that. Just said that, I know. And so this is not an option. So what I want you to remember is if I gave you a problem like this, let's say x squared, this is a quadratic equation, x squared is equal to, let's say 4, you would not try to factor it. You would look at it and say, oh, clearly, if x squared is equal to 4, x must be equal to plus or minus the square root of 4. And that continues on to tell me that x is equal to plus or minus 2. This is the concept that we're going to be exploiting when we complete the square. But we're going to build to it first. So what I also want to share with you is if I had x plus 7 quantities squared is equal to, let's say, 9. I could FOIL this out, move the 9 over to this side, see if I could factor, do something like that. But this is in a beautiful position for me. It's very similar to x squared is equal to 4. I can answer this question. What I'm going to do is take the square root of both sides, just like I did here. When I do that, I get x plus 7 is equal to the square root, or plus or minus the square root of 9. And so I get x plus 7 is equal to plus or minus 3. I'm not done yet because I need to actually answer this because I want to know what x is. I'm going to subtract 7 from both sides, and I get that x is equal to negative 7 plus or minus 3, and that means my answers are negative 7 plus 3 is a negative 4, and negative 7 minus 3 is a negative 10. So this is another way of solving quadratic equations. The beauty of this way, being able to have like a perfect square on one side and a constant on the other, which is what our goal is with completing the square, we get to solve problems that are going to factor out nicely, like this would have factored, and some that won't. So this is the technique of completing the square. To complete the square, we want one side of our equation to be a perfect square, maybe a perfect square trinomial, right? And then we want the other side to be some constant. And that's going to be our setup for completing the square. Let's look at some of these examples. So in this case, we're going to solve this thing, x squared minus 10x plus 25 equals 7, by taking the square root of each side. Well, look at this. You guys remember the last section of the last chapter? We talked a lot about perfect square trinomials. Here we got it. This is a perfect square trinomial. The ends are squared. The middle one is 2 times the square root of each of those guys multiplied together. So how do I factor that? I know that this gets to be factored as x minus 5 quantity squared. You can pause the video here and FOIL it out for yourself to make sure you're confident in what you got. So now we've got x minus 5 quantity squared equals 7. We're going to solve it just like we did talking about the examples earlier. We're going to take the square root of both sides. When I take the square root of this left side, I get x minus 5. When I take the square root of the right side, I got to remember my plus or minus the square root of 7. Look at this number really quickly. We would never get this number if we were factoring. These are irrational roots. Remember, when I get a radical of some sort that I can't resolve, we know that that's an irrational number. Let's go ahead and finish the problem. So I still need to get x by itself. I'm going to add 5 to both sides. When I do that, I get that x is equal to 5 plus or minus the square root of 7. And it said we can round our answer to the nearest tenth. Well, we will need a calculator for that. So I'm going to take a trip over to Desmos, where I have 5 plus root 7 is 7.6, and 5 minus root 7, our two answers, is 2.35, which I'm going to round to 2.4. And so let's take a trip back over to our answer choices here, or our options, and we see that we get 7.6 approximately. They told us to round to the nearest tenth, or 2.4 as our two answer choices. And that's what we got here. Does that make sense? I hope it does. I hope it seems reasonable. So the cool thing about this is we just solved something that we could not factor. If I moved everything over to one side, it wouldn't be factoring, but it did have a real answer, even though it was irrational. Let's take a look at this next example. So now we're going to find the value of c that makes this a perfect square trinomial. I like this. This is kind of fun for me. So you remember perfect square trinomials. We had a squared plus 2ab plus b squared, and we knew for sure we would factor that a plus b quantity squared. Well, we want to find a situation that we can use in that way, or we want to find a c such that we have a perfect square trinomial. Here's how we do it. We take the b term, right, and we cut it in half. Half of 6, or the coefficient of the b term, half of 6 is going to be 3, and then we take that term and we square it. All right, we cut it in half and then we square it. So we end up with x squared plus 6x plus 9. 3 squared is 9. And that's it. We just made a perfect square trinomial. Yeah, we did. We made it. We made it this thing a perfect square trinomial. So we know that c would have to equal 9. So in this example, they ask us to solve by completing the square. But if you notice over here, I don't have a perfect square trinomial. I'm going to have to make one. Please pay attention to this example. So I start off with a squared minus 14a plus 3 equals negative 10. The first thing I do is I'm going to take the constant term and move it over to the other side. So my equation looks like this. A squared minus 14a, move that constant over to the other side, negative 3 gives me a negative 13. Notice the space that I'm leaving here. I'm now going to add whatever I need to make this a perfect square trinomial. But remember, guys, this is an equation, so what I do to one side, I have to do to the other. So what should I add here? Do you remember the technique we just used back here? We took the b term, we divided it by 2, and we squared it to get a perfect square trinomial. That's exactly what we're going to do here. So the b term is negative 14a. When I divide that by 2, I get negative 7. When I square negative 7, I get a 49. What I do to one side, you got it, I do to the other. So I have on my left side rather, a squared minus 14a plus 49, and that's equal to the sum of these two will give me 36. And so now I can write this in its factored form. It's a minus 7 quantity squared. And you guys see what we have, a very easy way to solve an equation. We know we're going to take the square root of both sides, and we'll get a minus 7 is equal to plus or minus the square root of 36. We know that the square root of 36 is 6, so I can write this as plus or minus 6. Now I'm going to finish up our problem. A minus 7 is equal to plus or minus 6. Solve for a by moving that 7 over to the other side. That's adding 7 to both sides. And so my two answers are 7 plus 6, which is 13, and 7 minus 6, which is 1. Pretty cool, huh? When you see that it comes out to be a really nice answer like this, like integers or even fractional numbers, but not irrational like we got back here, when you see that, you know that we could have factored it, all right? Just a little bit of information for you. Let's take a look at this. We're going to solve this quadratic equation in which a is not equal to 1. So if you notice that this time we had a is, well, not a, but the lead coefficient was 1. The lead coefficient was 1 here. Lead coefficient was 1. All of that was easy. So now we have a little bit more of a challenging problem. So stay focused, please. Solve a quadratic equation in which a is not equal to 1. The paths of debris from a fireworks display on a windy evening can be modeled by a quadratic function. A function for the path of the fireworks when the wind is about 15 miles per hour is as follows. H is equal to all of this stuff here, where H is the height and X is the horizontal distance in feet. How far away from the launch site will the debris land? So if I'm thinking about this, I know that this is a parabolic function. Believe it or not, this lead coefficient tells me it's an upside down parabola or an unhappy parabola. If I haven't mentioned that, you will hear that later on. And so if I consider this the launch site, or the initial launch site, then this would be the landing. So in a way, I'm looking for the x-intercepts. I'm looking for the answer when this thing is 0, when the height is 0. So I'm going to rewrite my equation and just put that 0 is equal to negative 0.04 x squared plus 2x plus 8. And what we do when we have an a value or a lead coefficient that's not 1 is we make it 1. We divide everything by that lead coefficient. So I'm going to divide everything by 0.04, negative 0.04, and that's going to give me a lead coefficient of 1, which is very simple for me to use. So when I divide this into this, I get 1x squared, this negative value into this positive 2. I'm going to get a negative 50. Remember, this is a pretty small number. And then I'm going to divide this number, or I should say negative 400ths, into 8, and I get 200. All right. So now that I have that, I'm going to use the form that we just talked about, which is completing the square. When you complete the square, you want to make your a term 1 like we just did. You're going to move your constant term over to the opposite side. So I'll have 200 is equal to x squared minus 50x. Next, you want to add to both sides a value that will complete the square. What value will complete the square here? We told you that if you take the b term and cut it in half, you get a 25, and then you square it. That's how you write a completed square. That's how you write a perfect square trinomial, rather. So this cut in half is negative 25. Negative 25 squared is 625. What I do to one side, I got to do to the other. So this side will now become 825. That looks like a 23. 825. And this side we can factor as x minus 25 quantity squared, right? All right, that was a lot, but we're doing great. We're doing a really good job. Next, we need to solve it, and so we're going to take the square root of both sides, and we get that x minus 25 is equal to plus or minus the square root of 825. After that, we're going to finish off the problem by moving the 25 over to the other side, and we get that x is equal to 25 plus or minus the square root of 825. And so what I'm going to do is get the answers. So with a little help from Desmos, I got 53.7 as 25 plus the square root of 825, and I don't remember what the other one was. So I'm going to go check. 53.7 and negative 3.7 were my two answers. And so since we're dealing with a real life situation, the answer that's going to make most sense is the one that is positive. So 53.7 feet from the launch, the initial launch section is our answer, 53.7 feet. Okay, so with that in mind, I'm going to go back up and just talk a little bit about completing the square. So completing the square means that we make let's go back, we're going to create a situation where we have a perfect square on one side and it's equal to a constant, and then we're going to go through and solve that equation. We make the perfect square by making a perfect square trinomial. We do that, if we could look at our examples, we did that by making sure that the a value, the lead coefficient, is 1, and we take the b term, we cut it in half, and we square it, and we add it on to the end of the problem, and that makes a perfect square trinomial. So in a problem like this one, we threw all of the constants over to one side because we saw that we didn't have a perfect square trinomial here, and we added the perfect square, the half the b term squared, to both sides, and proceeded to solve. With this equation here, we had an a term that didn't work for us, or lead coefficient, so we divided everything by that term and then proceeded as we did before. I hope that's going to be helpful for you guys. I have a short assignment for you. Please take a look at it, work on it, and do your very best. Let me know if you need any help, and I look forward to talking to you soon. Take care.